We discussed question 1 and question 2 for A-level Pure Mathematics 3, paper 3, May and June of year 2020. Question 1. We are given an inequality. You have 2 times 3 to the 1 minus 2x less than 5 to the x. And we need to find the set of values of x which satisfy this inequality. And the answer in simplified exact form, so no decimals. X is in the exponent, so we need to use the law of logarithm. And recall that the product law of logarithm, you have ln of AB, that is given by ln A plus ln B. And also the power law of logarithm, ln of A to the B here, this is B ln A. So both can be replied in the reverse order. From the inequality, 2 times 3 to the 1 minus 2x less than 5 to the x. X is in the exponent. We can use the power law to bring the exponents down. We need x. So we can take log on both sides, preserving the order of the inequality. Then ln of 2 times 3 to the 1 minus 2x less than ln of 5 to the x. On the left side, you have ln of AB here. This is the product. We can apply the product law of logarithm so that ln 2 plus ln 3 to the 1 minus 2x is the left side. On the right side, we can apply the power law, bring these exponents down. We have x ln 5. Now, on the left side, we need to bring the exponent 1 minus 2x down. So we apply the power law. We have ln 2 plus 1 minus 2x ln 3 less than x ln 5. Expanding, we have ln 2 plus ln 3 minus 2x ln 3 less than x ln 5. We need to solve for x, so we can move this over to the other side, and these two can be grouped together using the power law. So ln A plus ln B is ln of AB. Then ln 2 plus ln 3 is ln of 2 times 3. We have ln 6 on the left side. On the right side, x ln 5, we subtract. So this is minus, then we have plus 2x ln 3. Okay, so we can actually write this in the other direction. It's more natural that way. X ln 5 plus 2x ln 3, this is greater than ln 6. So if you're flipping, you need to change the sign of the inequality. The sharp corner is just beside ln 6. That has to be maintained. Then we can factor x, and we have ln 5 plus 2 ln 3 greater than ln 6. Now let's look at these parts here. Ln 5 plus 2 ln 3, you have to write this as a single term because it is in simplified exact form. Then we can write this as ln 5. Use the power law here, and we have ln 3, bring the 2 back to be the exponent of 3. That would be ln 5 plus ln 9, which is ln 45 from the product law. Multiply these two. And this inequality is now x ln 45 greater than ln 6. We can divide throughout by ln 45, which is a positive value, and it doesn't change the inequality sign. That 2 cancel to be a 1, and x is greater than ln 6 over ln 45. That gives you the answer in simplified exact form. Question 2, we are to expand a binomial in ascending powers of x up to and including the term in x squared. And we need to simplify the coefficient. look at the exponent of the binomial. It is -2. So we look at the expansion of a general binomial. Then 1 plus x to the n here, this is given by 1 plus nx plus n minus 1 over 2 factorial x squared, and so on and so forth. Take note that the first term of the binomial must be a 1. N is the exponent. What we are given is 2 minus 3x to the -2. So we need to make the first term to be a 2. Now, inside this expression here, I can factor a 2. Then I have 1 minus 3 over 2x. And this can be written as 2 to the -2, 1 minus 3 over 2x to the -2. Then we can apply the binomial, the general binomial expansion on this part. 2 to the -2 is 1 over 4. Then for this case here, when we expand using that, n is -2. And then the x here is -3 over 2. Be careful with this negative. Then we have 1 plus nx. N is -2, x is -3 over 2x. And then add to n, which is -2, n minus 1 is -3 over 2 factorial, -3 over 2x squared. And we have 1 over 4. So -2 times -3 over 2 is a 3. It's a positive 3x. And for this part here, let's look at this part. That is -6 over 2, positive 6 over 2 factorial, which is 6 over 2, and that is a 3. And this part, when you square, we have 9 over 4 x squared. So we have a 3 multiplied by 9 over 4 x squared. So this becomes 1 over 4, 1 plus 3x plus 27 over 4x squared. And because we need to simplify the coefficient, you must expand so that we have 1 over 4 plus 3 over 4x plus 27 over 16x squared. And we have the expansion in ascending powers of x up to and including the term in x squared. That would be part A. Part B, state the values of x for which the expansion is valid. For this expansion to be valid, the absolute value of x, or the absolute value for the second term in the binomial, must be less than 1. So what we look at is actually this part here, the -3 over 2x. So the absolute value of the -3 over 2x must be less than 1. Absolute value of -3 over 2x can be written this way, and that is just 3 over 2, absolute value of x less than 1. So we just divide throughout by 3 over 2. In fact, you are multiplying by 2 over 3. So the modulus of x is less than 2 over 3. And this gives the set of values of x for which the expansion is valid.